Hello, everyone. Welcome to the session on polyglotism in vRO, VRLS Orchestrator. I am Sajal Debnath. I'm a staff consulting architect with VMware. Before I start the presentation, there are a few things that I need to mention that this presentation may contain product features or functionality that are currently under development. This is a standard disclaimer, though the presentation that I'm going to give does not contain any extra features. The features are subject to change, the technical feasibility and then market demand will affect the final delivery. Apart from this, the session is being recorded, but it's not going to be used publicly. So that's something that we need to be aware of. So I'm a part of VMware Professional Services, and I'm based out of Bellevue office, Washington State. And the agenda for today is I'm going to talk about what is polyglotism, then its relevance in software development, pros and cons of polyglotism in software development, how it's implemented in VRLS Orchestrator, the core concepts, guidelines, and then I'm going to give you a short demo on the functionalities of it. So if I look into the formal definition of polyglotism, it's actually the use of many languages, and a person who has the ability to speak multiple languages is a polyglot. That's the formal definition of polyglotism, or what is a polyglot. Now, what is relevance in software development? Traditionally, we have noticed that there are certain languages which are geared towards front-end development, and there are certain languages which are back-end development. And if you remember the software development, more than 10, 15 years back, there was a single programming language which we would be using to develop that end-to-end software. So traditional software development process. Whether it's suitable for developing every bits and piece of that software or not, we'd be utilizing a monolithic software programming language to develop that software. But then with the modern developments, with containerized applications, with multiple smaller fragments or microservices in a single software or application, we have the ability to develop different parts of that same application using different languages. So for example, just to give you an example, so if I'm using C or C++, that's a very good programming language to develop core functionalities, core operating system or device drivers or that kind of functionalities. But it's probably not best to develop front-end web servers or front-end web pages using C, C++. So I can have an application which has backend developed in C, C++, front-end using HTML, JavaScript, or CSS using those languages, and I have some middle tier applications or middle services which are developed in Python as well. So today's application, utilizing all those microservices, containers, and all of that, can have or is an amalgamation of multiple different programming languages. So that is polyglotism in software development, a single application using multiple different programming languages. That's where the comparison is. Now, what are some advantages and disadvantages of using polyglotism? So for example, let's look at the pros first. It simplifies the problem solving. Taking the same example that I was talking earlier, C, C++ is geared towards amazing core functionalities, device drivers, or core operating system functions. But using that same language to build a web server is going to be pretty challenging. Right? I will have to write something from core. So instead of doing that, my aim writing of an application is to solve some problem. So it simplifies the entire problem solving process. And at the same time, it provides better performance because now I can utilize a programming language which is best suited for solving a particular problem. So in essence, I get best of all the worlds and I can mix and match. That's pretty powerful itself. Also, I can have faster iterations. because inbuilt libraries, certain languages provide certain inbuilt libraries which I can utilize for developing that part. So my iterations becomes faster, and maintainability of overall application becomes easier because I have multiple parts. So those bits and parts, it's like divide and conquer role, right? So that gives me higher maintainability and increase in productivity. But at the same time, the problem that I'm going to face is I have too many choices. Like which one should I use for this part? That is a very hard choice to make. So too many choices is not always good. So that makes the uh, options a bit hard for me. And at the same time, for a single person to know all these programming languages, which is coming up new, which is better for which one, is hard. It becomes harder for me. And the other aspect of it is I now become a mercenary, which is I know all of these languages. Like for personally, I'm not a hardcore developer, but I know Python, I know JavaScript, I know C, and then some other programming languages, PowerShell and PowerCLI. But then am I an expert in all of them? Probably no. So that becomes a problem. And then maintainability, in the sense, now I need to, so maintainability is a so the pros, it's an advantage, but at the same time, it's a disadvantages as well, because I need to maintain all of these programming languages, they are in separate environments, they are dependencies and all of that. So these are a few of the pros and cons, but if you look at the advantages, probably I would still go ahead with it because it provides far more advantage than the disadvantages. In where is orchestrator now? If we come back to vRO, typically JavaScript is the default language. It has been traditionally been that. So it's still there. On top of that, I can utilize Node.js version 12, Python 3.7, or PowerShell 6.2 or 7.0. Both of these environments are there, and corresponding PowerCLI version 11 and 12 are there. So within vRO, I can utilize all of these different programming languages to write my workflows, to write scripts, and all of that. Now, if I look into the core concept, the major question that comes between workflows and actions, which one should I use first? Now, here, this is, I would say actions are independent entities, so I can maintain their life cycle out of workflow. If I write a script within a workflow and then I need to make change in that, so I need to make the changes to entire workflows. Whereas if I write modular scripts for actions, they becomes they act like small functions for me. So if I want to change something, I can easily change that. I can reuse that function to anything, any other workflows. So that becomes much more easier. So I would say if you're writing something pretty quick, pretty small, write it directly in the workflow. Otherwise, write a separate action for that particular task so that you can reuse that or maintain that life cycle. The other thing is when you write in script, using any one of the programming languages, the extra languages that they have, you need to define the function. So it's typically the handler function, and then it takes two inputs. One is context in which it's run, and the inputs that you are providing to this function. So that's the typical format. And then when you have entry handler, you need to mention what is the entry, and we're going to talk about that entry handler, how it impacts your naming of the function and what are the dependencies of that. The other important aspect of that, which is not pretty evident in the first place, but then when you define an action and write something in PowerShell, for example, or Python, you can set the memory limit. You need to tweak that because by default you have 64 MB memory.
Darn it.
Reminder to mute yourselves.
Yeah, please. Yes, please. So the memory limit is by default 64 MB, which will sometimes make the script fail because it doesn't have enough memory. So specifically, if you are using PowerShell or PowerCLI or Python, I would say set the memory, increase the memory limit so that you will not your workload run perfectly fine. So that's pretty important. The other thing is The inbuilt PowerShell, it comes with the following modules, which includes PowerShell, Power NSX, and Power vRO. So it is pretty much, I would say, pretty powerful. If you are interacting with VMware environment, using PowerShell gives you this extra added advantage so that you don't have to write everything from scratch. You can simply call those functions and utilize those in your scripts. Now, I'm going to jump over to demo, and I'm going to give you two demos. One is just to get edge node details. I'm going to interact with NSX, and I'm going to get the details of edge nodes, and I'm going to do that using JavaScript, PowerShell, and Python, all of that separately. And then I'm going to create and delete one edge node cluster profile in NSXT using pure play REST APIs. And then we'll be doing that using a single workflow, which has multiple different parts written in Python, PowerShell, and native JavaScript. So let's jump to the demo. Okay. So once I log into vRealize Orchestrator, I have a few of the workflows. The workflows are creating edge cluster profile, deleting edge cluster profile, and then three different scripts. One of three, all of them does the same task, but then one's written in JavaScript, PowerShell, and Python. So just to showcase that I can do the same stuff in different ways. So first, and there's a slight difference that I would want to point out. Let me just log into my NSX manager. And once I run that, first I'm running using the native JavaScript, and it's run. Look at the performance. It took 289 milliseconds. So this is native. Now, if I want to run that same task using PowerShell and see how much time it's going to take, it's going to take, it took 3 seconds, 301 millisecond. And if I run that using Python, the same task using Python. So the point being, since JavaScript is native, it's going to give you, always going to give you better performance. And between PowerShell and Python, Python runs faster because Python doesn't need that much memory and stuff. So while you are writing workflows, keep these in, if it's going to be performance intensive, or if you have performance in mind, keep this in mind that in native JavaScript is going to be always faster. And PowerShell also has that dependency where you needs more memory to run. The reason being, PowerShell or Python are non-native, so the environment gets loaded into memory and then it's run. So it takes much longer than the native way. So we could see that all three of them does the same stuff. The JavaScript, native JavaScript, I added NSX as an HTTP endpoint, and then I defined two REST operations on top of that. One is get, simple. I'm just doing REST operation, but then this is native call. So native JavaScript call, which is calling out that operation and just running that out. So that's why it ran that fast. But in PowerShell, it's pretty simple. I'm again have written a script, but it's just doing a raw call, invoke REST method, which is just doing a raw REST API call and getting that information. The same thing in Python, it's again a REST API call and getting that same information. Right? Now, these were basic tasks that I am doing. Now, I wanted to create few actions or separate out what are the things that I want to do when I'm running more complex workflows. So I wanted to create edge cluster profile and delete an edge cluster profile. But in order to do that, I wanted to keep checks. Like I want to get all the cluster profile and then check whether it's pre-created or not. So it's a bit complex than that. I will not say it's complex workflow. It's simple, but then it's more complex than the one that I've just shown. So I'm getting the edge cluster profile. This is PowerShell and PowerShell and then 7.0. Now this is the function. Whenever I'm writing some scripts, I have function, and then function name handler is the name, and then it takes context, which context is running, and then the inputs that I want to provide to that. For example, the inputs that I'm taking here is username, user password, and then display name. I take all of those inputs, and then I can work on those. So this is an atomic work, I would say. I'm just getting the edge cluster profile or edge cluster details, and then create edge cluster or delete edge cluster, which is pretty much similar to that. I'm utilizing PowerShell because of one advantage. In PowerShell, the environment that I have here lets me run the invoke REST method directly. But in the same thing, profile Python does not have that inherent the requests library. So that brings me to another way I can write scripts. So I can write direct scripts here, or I can import a zip file, which will allow me to run that script. So in order for me to do that, what I need to do is I just create a say folder, and go to that folder, create a lib folder under that, and then download all the dependencies on that under that lib folder. So whatever dependencies that you have, just get those dependencies under lib folder, and then write the script using this particular format. Now this format is pretty important because I've named it as handler.py. It can have multiple scripts under the same folder. The reason of handle.py is it's expecting that when that zip file is unzipped, it would have a file named handler, and within that file, there would be a function named a function named handler, and it has those inputs. So the input that I have is always handler.handler, or if I change the name, then I need to change the main file, and then that particular file may have multiple functions, but then it needs to have that function where it's the entry point within that. So if I want to create, say, for example, a new action, and then say, I want to write, say, Python, and then say script, I want to say zip, I need to say which is the entry handler. By default, it's handler.handler. That means the file name is handler and the function name is handler. If I change the file name or the function name, I need to modify it here. Otherwise, it's not going to run. So I wanted to point this out. So going back to my workflows, now this is a workflow where I'm using the same action, get edge cluster profile, just checking the cluster profile, whether it exists or not, whether it's found or not. And then I'm creating the edge cluster profile using the Python action that I have created. If I run that script, it asks me for, say, test one, and then I can simply give a profile description and run. And in NSX, I can go and check whether it has created the profile or not. So it created the profile test one for me. And if I want to delete the profile, I can simply go ahead and delete the profile. Again, the delete profile is get edge cluster. Now here I'm utilizing the same get edge cluster action, checking that. But to delete that, I'm utilizing another workflow, which is pretty much native JavaScript. So when I had added the REST operations under the HTTP, my endpoint, REST endpoint, NSX, which is NSX T manager, under that I have a delete function, delete REST operation. I'm utilizing that as a workflow, and then I'm calling that workflow here to delete that entire profile. So test -1, and then run that, it should delete that profile. So again, the native method runs always faster. So this is just a wrapper on top of that REST operation that I have. So this is just calling out those REST operation and then just running that for me. So if I go back and check my inventory, so my HTTP REST endpoint, it has two defined REST operations. One is get, the other one is delete. So instead of writing scripts, I'm just utilizing the native JavaScript or REST operations. So it would be running faster. But then the idea is I can write scripts or I can write workflows which can pretty much utilize all of that, native one, the Python, the PowerShell, all of that can be utilized in building complex workflows out of the workflows that I have, existing workflows or actions, and the rest of them. Now, generally, it's my best practice is when I'm running and writing workflows, and again, coming back to the original discussion that I was doing, that when to utilize workflows or scripting in workflows, specifically these extra programming languages, and when running actions. You note that I have this workflow. I take a scriptable task and then say scripting, and I want to utilize PowerShell. So whether the function and the format is same, there is no way, at least in this version, that I can define memory here. So if the script that I'm writing, if it's pretty big or if it requires more memory, there's no way I can define that memory parameter here. The only way I can define that memory parameter is when I'm defining an action. So in a way, it limits my choices, at least in this version. So if I want to write this action, I come here and then say PowerShell. You see this memory limit option comes here, and I can increase the memory limit. The function structure is still same. I can have multiple functions defined here, but then always the entry point is the handler function. So it comes to this function and then it can call to other functions. You can utilize it that way, but then the memory limit option is always here. So you need to keep that in mind. If you're writing a script which is going to be a bit bigger, you would have to depend on action. So it's always better to write atomic tasks. So get your task broken into smaller pieces, and then write those in actions so that you can utilize those into workflows. You can call upon those, and you can pretty much mix and match and write your own workflow utilizing either actions, hard-coded scripts, or other workflows even, for example, here. So this is how you would build your workflows or write complex tasks using polyglotism within work orchestrator, VLS orchestrator. In this version, these are the versions, these are the PowerShell, PowerCLI, Python, and Node.js, along with the typical JavaScript that we see. These are the options that you have, and you can do pretty much a lot of complex things utilizing these things. Any question? That ends the demo. I can go back to my presentation. And I would say at the end, please take your survey, and any questions if you have, I can check on this. Okay. Let me take the question. If we need to use other PowerShell modules not included as per the slide, we're adding the import module. No, import module in the script will not work. You will have to, because it's at the runtime, it's not going to reach out. So you will have to get those prepackaged. Like the way the example that I have shown for Python, you will have to build out those libraries, get those libraries, and then you can import them. Could you use REST call for JavaScript or NSXT have any plugin? I couldn't find any NSXT plugin for vRO at these versions. Earlier there used to be, But then the REST call, the JavaScript REST call, I did that. Direct JavaScript REST call you can do. Definitely, you can write hard code into JavaScript, or you can get those REST operations through the HTTP operations. And then the advantage in that way is you can reuse those operations in multiple scripts or multiple workflows. If you hard code something, or if you do a REST call into a particular script, you cannot utilize that script somewhere else. But then if you have those, is something like actions. So similarly, you use NSXT as an HTTP endpoint and then define the REST operations on top of that. You can use those REST operations to define other tasks. So that becomes easier. Is the extra time all due to loading the PowerShell interpreter? Is there a way to preload it? It's no way to preload it. It's just it loads the environment. Well, it loads the environment in the running memory space, and then that's a dependency. I would say that's what I've noticed. Will the lib folder structure work for PowerShell as well? PowerShell has its own modules format. It's not lib. I think it's a modules with their structure. Just need to check on that. The documentation for this is really good. So go ahead and check the documentation. You have a Git repo or some of these examples. These examples are pretty straightforward examples. I don't have a Git repo. I just had written those scripts as it's pretty straightforward, simple REST calls to NSXT. Okay. Is it possible to use PowerShell scripts with strict settings of error action preference equals to management automation action preference stop, and then rely on default error handler for exceptions that I forgot to catch within the code and rely? I need to check that. Typically, when you are running PowerShell scripts, you can definitely do that. Yeah, definitely you can do that. You can check the error action, but then orchestrator's ability to capture these errors in logs, in the sense orchestrator is depending on PowerShell. It's running that PowerShell environment. So whatever error that is coming from that environment. So if you stop error there, orchestrator is not going to see any error apart from saying that the script failed, because the script that is running, it's going to say whether it's ran fine or not. So you are not going to get the details. There are any codes for developers? I am not sure. I think there are various orchestrator courses, but I don't remember the name of the course. I believe that there is a course there. Would it be better to create smaller scriptable tasks or actions versus allocating more memory to a larger script? I would say that it's a task that's atomic. So if the task is atomic, write as action for that. Don't club multiple tasks which you can break into a smaller chunk of pieces into a single action. Take the actions as, or treat them as functions. So you don't you write functions for reusability perspective. That's the main thing. So I would say I at least my approach is like that. Is it possible to import shared third-party Python module for whole vRO appliance, or each project would have to use it? Unfortunately, the module import works only on that particular function, for particular action. So that's why I prefer using PowerShell, because it gives you much bigger functionality. Specifically, if I'm interacting with the VMware environment, I have PowerCLI, which gives me all these functionalities. I have 1 more minute. If you have any further question, you can reach out to my Twitter handle, or you can actually go to my blog site and post comment there, or you can reach out to my email ID as well, because I see many questions. Let me take that. So any Python module that you want to download, you just download it on the lib and pack it. The only problem is for each and every actions, you will have to pack those library modules. So that is pretty annoying, at least at this stage. Probably future versions would have better one. Can SaltStack replace vRO, or I still have to use? To me, the use case for SaltStack and use case for vRO are different. SaltStack is a state that you want. vRO is something that you want to do as a second day to action. So the use cases are different. Can you post your blog site in the chat? Sure. It's pretty simple. https://sajaldebnal.com. Okay, and I think I'm out of time. Thank you so much for your time. Have a nice rest of the day or evening, and don't forget to take the survey. Thank you.